I made my drone controllable by using only my hand. Drones can be controlled in many ways, but did you ever see someone controlling their drone by hand? Why am I doing this? I don't know, I think it looks cool. So I developed a plan. First, I need to capture my hand with a camera. Then I would need to locate my hand and extract computer-friendly data. Using the data, I would then classify the hand gesture to find the matching command and send it to the drone. Now the first thing is getting some video footage. So I started by coding the camera to get some visual input to work with. Next, I needed to extract information about the hand gesture shown in the frame. To do that, I needed some artificial help. Luckily, there already is an AI model that extracts so-called landmarks from hands in images. It's called MediaPipe hands and looks like this. Now it was time for the real challenge. Using the landmarks, I wanted to implement 7 different drone commands. Forward, back, top, down, left, right, and stop. There were multiple approaches to solving this problem. I had to decide between using geometric calculations and training an AI model on the landmarks. I decided to start with geometric calculations, and with some help I implemented geometric rules to classify gestures. To make detection more stable, I added some more magic. If you want to see the details, repo is linked below. In the end, it sort of worked, but it had clearly some problems. More on that later. Before testing the controls with a real drone, I wanted to simulate them in a 3D environment. After a quick setup, yes, I'm no 3D artist, I started testing the commands. Here, for example, I tried to fly a square. I learned 2 things from the simulation. First, I need a better simulation, and second, geometric rules won't do it for reliable control. That meant it was neural network time. And for a network to work correctly, you need lots of data. So I went data scavenging, because I didn't want to work months on creating and labeling my own datasets. Luckily, I quickly found a very promising dataset called Hagrid. It contains lots of pictures of people doing different hand gestures. But it had 2 major problems. First, the classes did not fully align with the commands I wanted to implement, and second, the data was simply too huge for my poor laptop to handle. I started by addressing problem 2. At first, I wanted to take the whole frame as input for the network, but I figured I could just take the landmarks instead. The advantages of that were more compressed representation of the data and also a simpler problem for the neural network to solve, because it only had to classify points instead of a whole image. But where do I get the landmarks from? That's where I had a stroke of luck, as Hagrid sample annotations already contained landmarks for each individual sample. So I extracted data with labels that were useful to me, and after a quick and simple augmentation to get the missing classes left and right, I just rotated the classes up and down. The data was ready. For the network architecture, I went with a simple 2-layer approach. Details once again in the repo below. Now it was training time. And the results really surprised me. Above 90% just from landmarks, but could it keep up in a live demo? To test it, I started my simulation, which had also seen an upgrade to make it move more drone-like. Can I beat my square flying time from before? Now that everything worked properly, it was time for the real drone. So I took my drone and went outside.